Assalamu alaikum, grade 9s. In section 10.2, we are going to be exploring chord properties. So before we get into the actual notes, I want to go over what you need to know for this section. So first of all, what is a chord? Remember, it's any line that connects 2 points on the circumference of a circle. Remember that in order to do this topic, things that you have to know, that the sum of all angles in a triangle has to be 180 degrees. You have to know that in an isosceles triangle, you have 2 equal sides and 2 equal angles. And you also have to know that whenever you have a right angle triangle, you can use Pythagorean theorem. Okay, so those are the things you have to know before we start this topic. The other thing is what are the chord properties? So there are 3 chord properties which are basically all talking about the same thing, which is the perpendicular bisector. And we talked about this a little bit in the introduction video, but we're going to talk about it again. So chord property number 1 states that the perpendicular, okay, from the center of a circle to a chord bisects the chord. So basically what it's saying is that whenever you have a perpendicular line from the center of the circle to a chord, a perpendicular line from the center of the circle to the chord, it will always bisect it, which means it cuts it exactly in half. It'll cut it into 2 equal parts. Okay, that's important because we can actually end up making triangles out of this. Okay, and we'll know that these 2 sides will be equal to each other. Chord property number 2 states that the perpendicular bisector of a chord in a circle passes through the center. So it's the same thing, saying that if you have a line that cuts a chord in half, it will pass eventually through the center of the circle. So chord property 1 and 2 are the same thing. So for example here, when you have this chord and you have a perpendicular bisector that cuts it directly in half, you know that it's going to go through the center. So it says, what is x? X is the center of the circle. So that's chord property 2. Chord property 3 says that a line that joins the center of a circle and the midpoint of a chord is perpendicular. Again, it's saying the same thing. Whenever you have a line that connects the center of a circle and the center of a chord, it's going to be perpendicular, which means it's going to create a 90-degree angle. Again, that's important because we're going to end up using 90-degree triangles. Okay, so here, what is the measures of angle x and angle y? Well, you have a line from the center of the circle to the center of the line. That's going to be a 90-degree angle. Same with this, it'll be a 90-degree angle. Okay, so we're going to go through some of the notes, and then we're going to come back to the some examples in this separate section of notes. By the way, guys, these notes are on my Google Classroom under chapter 10 notes. Okay, so these are just a different type of notes with different examples that I'm going to be referring to. Okay, so working example number 1, so it says bisect a chord with a radius. So it says radius CD, so from C to D, it's a radius because it goes from the center of the circle to the edge of a circle. It says it bisects the chord AB. Remember, bisect means that it cuts it in half. And chord AB is actually 8 centimeters long, and the radius is 5 centimeters long. So then it says, what is the length of line segment CE? So it just wants us to figure out how long is this line right here from here to here. Okay, so what are some things that we know? We know that the radius is 5 centimeters. So all of CD is 5 centimeters. But also CA is also a radius. It's also 5 centimeters because it goes from the center to the edge. And we know that AB, the entire thing, is 8 centimeters. Now, when a line bisects a chord, it cuts it in half. So if the whole thing is 8 centimeters, then that means that this section is 4 and this section is 4. Okay? So let's go through this information here. So it says CD is a radius that bisects the chord AB. So therefore, if it bisects it, then it has to be perpendicular to it. If it's perpendicular to it, that means it makes a right angle. So angle AEC, this angle is 90 degrees. Okay? So CD divides AB in half, so that means that section AE is equal to section EB. They're directly cut in half and they're equal to each other. AB is equal to 8 centimeters. So that means if it's cut in half, AE and EB are both going to be 4 centimeters because it's half of 8. And we know that AC is also a radius, like I said. So it's going to equal to 5 centimeters. So we're going to label it on the diagram, just like I did. And now you have this situation here, okay? So since AEC is 90 degrees and you know two side lengths, you can use the Pythagorean relationship to find the unknown side length. Because if you look here, you have actually a right angle triangle. And this CA is a radius, so it's 5. AE is half of the chord, so it's 4. And CE is this side length that we're actually trying to find. We have a right angle triangle. We can use Pythag to do it. So here we have C squared minus A squared equals to B squared. Remember, the C side is always the one that's directly across from the 90-degree angle. So 5 squared minus 4 squared will equal to B squared. So 25 minus 16 equals to B squared. So B squared will equal to 9. And then to get B by itself, you have to actually square root it. And that means that the side B is equal to 3 centimeters. Okay? And the side B is the one we're looking for, which is CE. So it's 3 centimeters. Okay? So the length of CE is 3 centimeters. All right. So what I want you to do now is I want you to pause the video and try the show you know using the same strategy that we just did. Okay, so pause, try the show you know, come back and check your answer. All right, guys, so you should have figured that CH is a radius that bisects the chord FG. GC would then be 6 centimeters, which is half of 12. Angle GJC is 90 degrees because it's a perpendicular bisector. Then if you do A squared plus B squared equals C squared, you would get that the missing side is 8 centimeters, which is CJ. And guys, always remember that the hypotenuse has to be the biggest side. So if it's not your biggest side, then that means you labeled something wrong or you did something wrong. Okay, so that is the show you know. This last page of the notes we're not going to do. It's not something that you're going to be tested on. So instead, I'm going to actually go through some of the examples on the other set of notes that are online. So let's look at some examples here. Okay, so point O is the center of a circle. The line segment OC bisects the chord AB. And then it says OAC is 33 degrees, which is right here. And then it says determine the values of X and Y. So the first thing we should know is that since OC bisects the chord AB, that means there's a 90-degree angle here and here. I know it doesn't ask for that angle, but you need it to solve for the other missing angle. So for example, here we have a triangle, and we know 2 out of the 3 angles that are missing. So all we have to do is we have to just do 180 minus 90 minus 33 to get Y, which is 57 degrees. And then for X, right here, okay, we have an isosceles triangle, right? We have a triangle made up of 2 radii. So if this side is 33 degrees, that means X is also 33 degrees. And that's how you solve for X right there. Okay, so X would be 33 degrees and Y would be 57. Okay, here's another example. So it says point O is the center of a circle. AB is the diameter. Okay, this is important because if you know the diameter, then you know the radius, how long the radius is. So AB is a diameter with a length of 26. CD is a chord, okay, that is 10 centimeters from the center of the circle, what is the length of the chord CD. So if you look here, okay, from A to B is 26. And then it says CD right here is a chord that's 10 centimeters away from the center, okay? So from here to here is 10 centimeters. And it wants us to find the length of the chord CD. So with this topic, you guys, whenever you need to find the length of anything, you need to make a right angle triangle somehow, okay? So what you should recognize right here is that you have a right angle given right here because it's a bisector, okay? Now, the only lines you can draw to make right angle triangles are radii, okay? You can only draw a radius or a diameter, but specifically a radius, to make a triangle in order to be able to do Pythagorean theorem. So where can we draw a radius to make a triangle with part of this line? Well, you can draw, this is the center, so you can actually draw a radius from here to here. And we know that the radius would be half of 26, which would be 13. Or you can draw a radius from here to here, which would also be 13 centimeters. So you actually don't need the diameter that they drew for you at all. The only reason you need the diameter is to know the length of the radius. So let's say we're going to focus on this triangle right here. We know that this side is 10 centimeters and this side is 13. We can find the bottom. We don't know what the bottom side is, but if we find the bottom using Pythagorean theorem, then that's part of the chord that we need to find. And specifically, it's actually half of it. So if we find the length of this side, we can just double it to find the length of the whole chord. So that's how you would go about solving this question. So then you would do 13 squared minus 10 squared equals b squared, or the side squared. And so 13 squared minus 10 squared, 169 minus 100 is 69. And then you square root them, you get that the side length is 8.3 centimeters. Okay, so that's not the question though. So 8.3 centimeters is just from here to here. So this would be 8.3. But the question asks, what's the length of the whole entire chord from here to here? So if this is 8.3, then all you have to do is times it by 2 to get the full length of the chord, which is 16.6. Okay, so that's another example of a question that you could have to solve. This type of question is actually really common, okay? So here we have, it says a horizontal pipe, okay? So you have these pipes in the diagram right here. So it's a circular pipe, okay? It has a circular cross-section with a center O. So we're just looking at this, we're just looking at this part of the pipe, okay? So it has a circular cross-section with a center O. Its radius is 20 centimeters, and then it says water fills less than 1/2 of the pipe. So there's like water on the bottom of the pipe, okay? The surface of the water from here to here, the surface of it is 24 centimeters wide. So this whole thing is 24 centimeters. Determine the depth of the water, which is the depth of C to D. Okay, so from here to here. So how would we solve it? Okay, so here we have our circle. Okay, we have our radius, which is 20 centimeters. We know that the whole thing AB is 24, which means that this is 12 and this is 12 because this is a perpendicular bisector, which means it cuts it in half. Now, we have a right angle triangle right here, and we have two of the given sides, and we can find this unknown side using Pythag. Now, why would this side help us to find the depth of the water? Well, if we find this side right here, we know that from O to D, this whole thing is a radius, right? Because it's from the center to the edge. If we find this part, then we can subtract it from the radius to find the depth of the water. So that's how we're going to go about solving it. So we're going to do Pythag in order to find from O to C. Okay, so 20 squared minus 12 squared gives us 400 minus 144, which is 256. And if we square root it, we get 16. So this side would be 16. Now we know that from O to C is 16. And we know that from O to D is a radius, so it's 20. So from O to D is 20. From O to C is 16. Can we find how much this tiny piece is? Well, yeah, you just subtract them. So 20 minus 16 is 4 centimeters. Okay, which makes sense if you look at it. So if this red part is 16, the blue part has to be 4 in order to make the whole radius 20. Okay, so the depth of the water is 4 centimeters. Here's some more questions. These ones are a little bit quicker. So point O is the center of the circle. Determine the values of angle D, length E, and length F. So here, if O is the center and a line cuts a chord in half, how do you know it's cutting in half? Well, it has these two ticks on them to show you that they're equal. Then that means this has to be a 90-degree angle. Okay? And then, so if you have a 90-degree angle, you know that this line was cut in half. So if this side is 5, that means this side is also 5. And here, if the whole chord is 14, and you have a perpendicular line that cuts it in half, that means F is 7. Okay? All right. Here's another example to find some missing angles. So it says determine the measure of angle X and angle Y. So here we have this angle right here is 22. So this is an isosceles triangle, which means that X has to be 22 degrees as well. Because it's isosceles, it's made up of 2 radii. We did this in 10.1. And we know that all the angles have to add up to 180. So you just do 180 minus 22 minus 22, which would get you 136 degrees for Y. Okay, and then for this one, again, we have an isosceles triangle. Okay, we have the central angle is 110, and X and Y have to be equal because it's isosceles. These are 2 radii. So you would do 180 minus 110, which should give you 70 degrees. And then you divide that by 2, which should get you that X and Y are both 35. Okay. Here's another example. So point O is the center of a circle. Determine the values of A and B. So here we have A is from here to here, and B is the length of the whole entire chord. So in order to find B, you need to find A first, okay, because B is double A. Now here we have a right angle triangle. We have, here's the center to the edge, that's our radius, which is 7. And then from here to here is 4. So in order to find A, you have to do C squared minus A squared equals to B squared. Why is this one C? Because it's exactly across from the 90-degree angle. So then you have 49, because 7 squared is 49, minus 16 equals to B squared. Okay, 49 minus 16. 9 minus 6 is 3. 4 minus 1 is 3 is 33. Is equal to B squared. So to find B, which is actually, I'm going to change this to A so it's not confusing. I'm just changing it to A because it's actually labeled as A. Okay, so if you square root 33, A would be equal to 5.7. And then B is the full length of the chord. So you just do 5.7 times 2 to get B. And that would be 11.4 right here. Okay. Another example. So point O is the center of each circle. Determine the value of R. Okay, so here we have the center of our circle. It wants us to find the length of this line right here. So it gives us the length of the chord SU, which is 16, which means that here is 8 and here is 8. And we know that the diameter is 20. So remember, we need to make a right angle triangle, and the only way we can do that is by drawing a radius somehow in order to make our triangle. So you can actually do it this way or this way. It doesn't matter. So let's say we did it this way. We know that this is a 90-degree angle because it bisected the chord in half. And so this would be 10 because it's a radius. And then you would just do Pythagorean theorem to find r. So 10 squared minus 8 squared would equal to r squared. So 100 minus 64 is equal to r squared. And then if you square root it, you get that r is 18.3. Here's another one. So point O is the center of the circle. Determine the value of S. So here, it's a little bit trickier, okay? This is the center of the circle, and it wants you to find S. Now, S, the first thing you might think is to do it, look at it like this as an isosceles triangle. But whenever you're trying to find the side length of a triangle, you have to use Pythag. And in order to use Pythag, you need a 90-degree angle. And with an isosceles triangle, you don't have a 90-degree angle. So you can't use this isosceles triangle. What you need to use is actually this, sorry, not that. You need to use this right angle triangle right here. Okay, so we know that, and now how does that help us? So if we know that this whole thing right here is 6, then we know that this side is 3 and this side is 3. Okay, and then we know that this is 4 because it says this is the same as this. So this would be 4. Now, in this right angle triangle, we know this side is 4, this side is 3. We can find this side. Now, how does that help us find S? Well, S is part of this one bigger right angle triangle. So if we can find this side, and we know this side, then we can find the hypotenuse here. So we're going to do the mini right angle triangle first in order to find this missing side, so we can do the big one later. Okay, so you would do c squared minus a squared equals b squared. So 4 squared minus 3 squared equals to the missing side length squared. And then so it's 16 minus 9 equals, let's say, a squared. Okay. Sorry, 16 minus 9 is 7. Equals to a squared. And then you want to square root it to find our missing side. So when we do that, we get that our missing side is 2.6. So this is 2.6. So now we found the mini right angle triangle. We can use that to find the big right angle triangle. So if we know that this is 2.6, then that means the whole side is 4 plus 2.6, which would be 6.6 right here. And we know that this is still 90 degrees. Okay, so we have 6.6, we have 3. We can find our hypotenuse by doing a squared plus b squared equals to c squared. So 6.6 squared plus 3 squared is equal to c squared. And if you solve this, you would get that the c, or the hypotenuse, is 7.2. Okay? So that's it for, those are just a bunch of different examples for 10.2. That's all we're going to do for today. I know it's a lot. I just wanted to make sure that you guys saw a bunch of different questions that you might see on your homework. Okay, so your 10.2 homework or your assignment is page 389 to 392 of your textbook. Questions 4 to 18, only the even ones though. Okay, so 4, 6, 8, 12, and so on. This is your assignment for 10.2. Your help session will be tomorrow, inshallah, where you can ask your questions about this section. I hope this lesson was informative. That's all I have for you guys today. I will talk to you soon, inshallah. Assalamu alaikum.